Hello? Okay. Yeah, welcome everybody to my talk about real-time analytics with Flink and Druid. Yeah, my name is Graßegger, and I'm working as a data engineer at MBR Targeting. MBR is doing real-time advertising. Means that we are providing a demand-side platform, DSP, to help advertisers reach their customers more efficiently. And the last time we were working on a real-time analysis and reporting tool, and this is very important for us and our customers to get live insights into their campaigns that are running on our platform. But this task is not that trivial, since we have some data, like 70,000 events per second. Each of these events has up to 50 different dimensions, and we are calculating 20 metrics based on these events, event types, and dimensions. So this is kind of a lot of data, and we had to look for storage that is able at first to consume that amount of data and show it to us immediately, and that is also able to handle queries where we can combine any dimension with each other and get a response in an acceptable amount of time, like in under 1 second or so. And we were also looking for an open source solution. And since the problem is quite hard and it's not easy to solve with relational databases or key-value stores, since you have dimension with a quite high cardinality, like top-level domain or whatever there, you have millions of entries, of different entries in these columns. And for example, for a key-value store, you would have to pre-compute all the possible combinations of these different dimensions. So we were looking for storage that does all this for us, and we found Druid. Druid is an open source online analytical processing system that is made for this purpose, for having high dimensional data and querying it very fast, and also it has capabilities to handle this data in real time. Yeah, it's a column-oriented storage. It's distributed. Distributed means that you have multiple different roles, like a real-time node that handles the real-time data, a historical node that is able to read historical data also from distributed storages like Hdfs or S3, and you have a broker role that knows where to query forward data and where your queries have to go to. It has built-in data sharding capabilities. Means all your data is organized in so-called segments, and these segments are sharded by time. When you create data in Druid, you're saying, yeah, I want segments that contain data of 1 hour or 1 day or 1 minute and whatever. And you query Druid with a JSON query language via REST-like HTTP API. So the question is now, what makes Druid fast, and how is it able to handle these multi-dimensional data? And one thing is that it's the way how it creates the data structures. For example, we have a column of top private domains. Here we have 2 different domains with 2 entries each. And what Druid does, it maps all string values of columns to integers. And so it is able to encode the column data very efficiently. It's one thing. So this shrinks the amount of data by a lot. And a second data structure are bitmap indices. That means for every column it stores is that value in that column or not. So if we have, for example, we have BattleNet in the first 2 columns, so it stores a 1 for these 2 columns and a 0 for the other columns. And this makes it quite efficiently to filter on entries. Like, for example, if we want all entries that contain BattleNet and Noxicom, we could do OR operation on these 2 arrays and get all columns that contain these 2 entries. Yeah, that's on data structures. Now it's the question, how do we get our data into Druid? And there are so-called fire hoses, which are the data ingestion capabilities of Druid. And usually they are stream pull-based, means that you create these fire hoses via the JSON API, and then you give a local file path or a Hdfs file path, or you give a Kafka topic. That's possible, but what we finally wanted for our system was something different. We wanted to push data into Druid, to read it from a stream that comes from Kafka, and put it, transform it a bit, and then put it into Druid. And so now we decided to use Druid as our storage, which was because it was quite impressive to us. But we needed some other tool to put the data into Druid. And so we took a look at Flink. Flink is a platform for distributed stream and batch processing. But the interesting thing on Flink is that everything is stream-based. So you can work on every single event. It's quite nice. Yeah, I think the talk afterwards will get more deeply into Flink, so I will keep it short. But Flink is really nice to work with, and so we came up with these briefly kind of architecture or our design, how we want to process our data. We want to consume it, we have it in Kafka, want to consume it with Flink and put it into Druid. Now, the question is how to combine Flink and Druid. And there's a tool, a sub-project of Druid that's called Tranquility. And Tranquility is made for this purpose of putting real-time data push-based into Druid. And it provides several adapters, like for Samza, Spark, Storm. And now it also contains a Flink adapter because we committed it to the project, but it was quite fast forward to do that. And now it also has a Flink sync that enables you to easily put your data into Druid. It also provides some standalone HTTP server or Kafka application where it reads data from Kafka and puts it into Druid, but yeah, doesn't matter for us. So now we know how to put the data from Flink to Druid, but there was one open problem that we discovered, or 2 things that were still missing. And the main thing is how are we doing replays with this architecture? Because Tranquility is really made for the purpose of putting real-time data in. And it's made with the, there was an image, it doesn't matter. Made from the idea of a Lambda architecture, where you have different processing paths for streaming and for batch processing. Means that you put data, here's the image, means that you put data via streams in real time into Druid, but you reprocess everything again with Druid and reading it from Hdfs and use that as your ground truth. So if we would have gone with this kind of architecture, we would have to maintain 2 different code paths, 2 different tools that put the data into our storage, and also to prepare the data for Druid and write it prepared to Hdfs, and this is something that we didn't want. What we would like to do is to put this together to have to have like one code path that processes everything. And so we came up with Kappa, of the idea of a Kappa architecture. And the Kappa architecture relies on the idea of that streaming is more reliable nowadays. That you can also have a ground truth only based on streaming. But there was one thing, that the idea of Kappa is like you're just working with Kafka. You have like 30 days of your data stored as historical data in Kafka, and if you want to reprocess something, you just read the Kafka stream again. But in our case, we have a lot of data already in our warehouse. We have like almost all data that ever came to us in our warehouse. So we would like to be able to process that and not to store it also in Kafka. And so we came up with this kind of an idea of an architecture where we have Kafka and Hdfs as sources for Flink. And that these are the only two, that the sources are the only difference in the code path when we want to process our data. I still think it's a really nice idea, but it was really, really hard to achieve that, because Druid was really designed, and also Tranquility was designed to work with Lambda architectures. Like for example, Tranquility drops every event. That is, if you have segments that are partitioned by hour, for example, then it drops every message that is older than 1 hour. And there was not built in to be able to add older data, and also in Druid you cannot reopen a segment. You have to delete it and then create a new one. And all of this we had to at first find out and then implement it on ourselves. But this is something that we finally achieved. So now we have this Kappa-like architecture that is able to do replays from Hdfs and Kafka, and does everything with Flink, with the same code path, with the streaming API of Flink. And yeah, that's what was quite nice to achieve. And to sum it now up a bit, yeah, as I already said, we already committed the Flink sync to Tranquility. We have these kind of hacked replays that we added to Tranquility, but this is still in our repository. We are going to try to commit this to Tranquility, but I'm not sure if they will accept it. But you're still free to have a look at our Tranquility repository from MBR targeting. It's also on GitHub. So yeah, and finally, the final goal that we want to reach is to have a real-time reporting and analysis tool. That's something that we achieved, and yeah, that was quite cool and an interesting way. We learned a lot on this way. Yeah, thank you very much. Questions, please.
Okay. I'm running.
I'm curious about how you got it all together, like the iterators in Kafka, the checkpoints from Flink, the Druid segments, and I guess the Hadoop files or partitions. I mean, they all have to be in sync. Can you tell us a little bit about that?
Yeah, we have, let's start with the data in Hdfs. So that's something we already had, and it's partitioned it's already partitioned by hour. These are Hive tables that are partitioned by hour. Then we have these Flink job that runs all the time and fetches the data from Kafka and does checkpointing. So if it fails, it starts again on the same offset. And so it's quite simple because we also have to do some joining in our pipeline, but that is all happening before. So we are just reading already joined events, transforming them and filtering out the dimensions we don't need for Druid, and then it runs all the time. If it fails, we just restart it, and it keeps up running. And the Hdfs Replay is something that is more that we developed to handle failures, either in the workflow if a node crashes and we have there for some reason are events missing, or if something was misconfigured in our campaigns or so. And then we are able to start these replays manually. So we are not doing this Lambda architecture where it's usually works the way that you do the streaming all the time, but you always overwrite the data with the batch process. That's something we are not doing. Yeah.
Okay. 1 more minute left for questions. Oh, just give me a sec. I'm here.
Have you tried to send the message from Hdfs back into Kafka and reuse your flow? In a production system, I did something like this, but the amount of data that I have to send back to Kafka is very limited in my use case. But in yours, because you have to do the full processing, yeah, if you have to recompute everything, I expect you to have to send a lot of data back into Kafka.
Yeah.
Kafka probably more than the 30 days. Let's say you want to recompute a full history, but yeah, in that case, you would really need to be able to read from Hdfs, but it's just an idea. You guys can send the data from Hdfs back into Kafka into a different topic, and if the data to reprocess is not that much, you can reuse the code that reads from Kafka.
Yeah, yeah, we thought about it, but the point is that it's kind of trivial to read from Hdfs with Flink. So to write a process that to develop software that puts it to Kafka again, and then you read it from Kafka, it's more complex than just reading it from Hdfs, and it's both data is in the same format. So it's really, for us, in our case, it's just the difference of the source, and the data is equal, and so it wasn't really a challenge to have to read from Hdfs, and it works quite well.
Okay, thank you. With this question, we should finish this session, and in 10 minutes, we will continue with another session on a Flink topic. Thank you.